Good day. My name is Manuel Alejandro Sánchez Fernández, and I'm a researcher at Instituto de Humanidades y Ciencias de la Conducta in Mexico. And I will be presenting the work named Latent Semantic Analysis for Tagging Activation States and Identifiability in Northwestern Mexican News Outlets. On behalf of the other two authors, Dr. Alfonso Medina Urrea, del Colegio de México, and Dr. Juan Manuel Torres Moreno, from the Laboratoire Informatique d'Avignon, Université d'Avignon in France. The objective of this work is to present the results of experiments where latent semantic analysis, LSA, and a variation called span were used to automatically identify in known phrases the speaker's assumptions about the ability of the listener to identify a referent or habit in their attention. This, in pragmatics, has been analyzed as cognitive identifiability and activation states, and they are part of sentence and discourse analysis. Instead of trying to solve the big issue about what is new given in a text, we reduce the problem to explore if the measurements obtained through LCA and span have any correlation with these linguistic concepts present in the known phrases. As to say, the contribution of this research is to state if we can use these measures to create a method for automatic identifying linguistic categories that theoretically are related to the new given distinction. To achieve this goal, I will talk about the notions of new given in linguistics, a brief review of latent semantic analysis and its variation span, the way the corpus was created and organized, the groupings that serve in the experimentation, and the results of the statistical evaluation that consists of Pearson's error correlation, variance analysis, and an exercise for classification using random forest. Now, for the notions of the new given in linguistics, it is recognized that the speaker is responsible for shaping the speech based on assumptions about shared knowledge, inference capacity, or attention. These three areas are worked on as assumptions about the mental states of the reference and are based on three cognitive capacities: long-term memory, short-term memory, and working memory. Different linguistic structures are examined to find these assumptions, and among linguists, not a single way to do this kind of analysis will be found. Therefore, it is not obvious to determine which fragment of a text is best suited for novelty analysis. Nonetheless, one of the structures commonly analyzed to look up for these assumptions are the referential devices. There are two ways in which references are formalized in discourse through referential devices: reduced and full. The reduced forms, in the case of Spanish, are pronouns, marks in the verb, and null morphemes. They imply that the speaker, when articulating such construction, supposes that the listener has in their working memory that referent in mention. On the other hand, if a full referential device is used, a noun phrase, it articulates the speaker assumptions that the referent in question is not found in the listener's working memory. He may appeal to a referent mentioned at another point in the speech or text to share knowledge outside the conversation, or he may want the speaker to conceptualize a new referent. In this work, only full referential devices were analyzed because most of the work in computational linguistics related to this topic focused mainly in the reduced ones. There is a consensus among the authors that the mental states of the reference, the assumptions about the state of the referent, are divided in two types: identifiable and non-identifiable. The identifiable ones are then divided into active, accessible, and inactive. After this division, each author proposed a different diversification. The problem with this and other types of division is establishing homogeneous linguistic criteria for analysis. In this case, we took what is proposed in Sánchez Fernández 2021, another work that I had proposed. We follow the method that is described in that work, and rename the mental states of the reference as informative states to allude to the fact that they were created to associate new given information in a context of computational analysis. Therefore, in a text divided into noun phrases and sentences, each noun phrase will have an informative state. Now, latent semantic analysis is a method that captures relationships between text fragments from their lexical co-appearance. The interior of the fragments or the exterior lexical context of appearance can both be used as backup words, which means that the word order is discarded. These bags are treated as matrices, where each word is a dimension and each vector the fragment analyzes. The cosine separation measure is calculated between these vectors to determine the degree of relationship. The span variation was thought in the context of using LCA to measure the amount of new information of a constituent with respect to a series of previous constituents. In the case of LCA, the cosine is calculated only between an incoming vector and the vectors preceding it in a text. Among the different measures, the highest is taken, which means that at least one of the previous fragments is related to the analyzed fragment. This variation of LCA is called LCA max. In the present work, the LCA measure implies only this selection unless otherwise is indicated. In span, because the LCA method involves singular value decomposition, a base is created with the set of previous vectors. The vector of the analyzed fragment is then projected onto this hyperplane. The projected vector is the amount of information considered given, while the orthogonal vector is what is considered new. The formulas for this method can be found in Landauer 2007 and in the article in this article in particular. And in Sanchez-Fernandez 2021 can be found a step-by-step description of the method. Now, for the corpus, 2,388 noun phrases were extracted from a subcorpus of 38 news articles. These were randomly selected from the Corpus Periodístico del Noroeste de México, which consists of a total of 380 news from digital media from the states of Baja California Sur, Chihuahua, Durango, Sinaloa, and Sonora from Mexico. The preparation of the corpus for the experiments were conducted as follows. First, there was a manual labeling, which consists in two stages. In the first one, nominal phrases and sentences of the 38 notes were analyzed. In the second one, the informative states were analyzed, and this property was assigned in an XML format. As stated, we follow the method of linguistic analysis for informative states as described in Sanchez-Fernandez 2021, and in Sanchez-Fernandez and Medina-Urrea 2020, a more comprehensive review of the corpus manual labeling can be found. Now, the second stage was an automatic labeling. For each noun phrase, the lexicogrammatical properties were analyzed through the stance automatic tagger, in addition to lemmatizing both the interior and exterior backs of words. In this way, the lexicogrammatical properties of the noun phrase were part of the interior back in the same ways as its lemmas. Once this analysis was carried out, with a routine in Python, LCA and span were calculated. Now, in order to compare results, two groupings of informative states labels were chosen. The first is the one observing the last figure, where all the initial text can be seen. The second one is a reduced version that obeys a more operative criterion, identifying references that are mentioned within the text and those that are not. For this case, in this binary category, the text not identifiable low, not identifiable, inactive in long-term memory, accessible by frame, and accessible by Origo were grouped into outside the text, while within text, we can find the text inactive in discourse register, active subject, active object or indirect object, a direct object or indirect object, active by a by a preposition or present in a preposition, and identifiable low. Now, for the descriptive statistics, for the complete tag set, the distribution looks as follows. The label with the highest number of observations was not identifiable, with 1,195, followed by inactive by discourse register, the three here, with 406. The one that obtained the least amount of observations was active per indirect object with 7 here, followed by accessible by Origo by 29 that have the 8 code for this tag. To point this low frequency is, pointing this low frequency is relevant because it is observed that the case in which the noun phrase formalized assumptions of active informative states are less likely, aspect that is coherent with the linguistic theory. For the reduced grouping, out of text obtain 1,734, and while within text consists of 654. Now, for the study of correlation, as for the Pearson correlation, it was found that only one of the bags that used the exterior of the phrases show correlation with LCA, but none with span. However, for the interior, it was different. In the case of the SYN-C tags, those that show mild to moderate correlation are shown in Table 2, from where we can point that the best correlation can be found between inactive by discourse register and inactive with LCA interior with 0.5. For other tags in SYN-C, no remarkable correlation was found, and I have to say that it had other 9 tags or 8 tags. No? In the case of the reduction of two groups, in this case, the following was found, shown in Table 3. Again, using the exterior window of the phrases shows low correlation, where span exterior does not show any correlation at all. And again, LCA interior shows the best correlation. To determine that the groupings of the noun phrases using the measures and the tags offer us differentiated sets, a variance analysis was carried out. In the case of SYN-C, the results are shown in Table 4. As can be seen, the highest statistic is obtained for LCA interior and the lowest for span exterior. This makes sense with the correlations found, where the measures using the exterior bags did not show a strong correlation with the labels. If we carry out a more detailed inspection through its box plot, we observe that there is no label well differentiated from another. That is this one here, span exterior. Almost everyone crossed with each other. However, it is precisely the LCA measure with the interior bag here that shows the greatest contrast. For the SYN-R, ANOVA showed the following results. For this analysis, it stands out even more that exterior windows does not show a comparable statistic with interior windows of the phrase. LCA with interior bag also shoots up to 5 times more than the closest measure. That is this one, leaving far behind the measurements that use the exterior bag, that are those two. Now for the random forest, in order to test the ability of LCA and span measures as predictors of informative states, this kind of experiments was carried out. However, it should be taken into account that this classification exercise is only a preliminary test of the capacities of these measures to be used as predictors, given the results observed in the ANOVA and the correlations. For the classifier of the 10 SYN-C tags, the best model with the lowest error in the labeling of the test set generate 150 trees. The maximum branching was 3 expansions per tree, and the gene impurity criterion was used for the evaluation of the nodes. 66% of the 2,388 nominal phrases were used in the training model, and 33 were used for the test. The first thing that can be highlighted in the results shown in Table 6 is the inability to classify informative states aside of inactive by discourse register and not identifiable here. It should be remembered that this model used the 4 measures, although they end up with different weights, as you can see in Table 7, related to the performance of the classification. Based on the mean and the standard deviation of the impurity decrease in H3, the importance of H predictor is calculated as shown. It can be seen that is LCA using the interior bag of words that has the greatest importance in contrast to span, in which neither bags provide information for classification or very little. However, LCA in interior seems to work to distinguish only certain informative states, not all. For a scene R, the model that yielded the least error was the one that used, again, 150 trees, a depth of 3 branches, and used the Gini purity criterion in this as the last random forest experiment with the scene C. In the same way as the previous case, the corpus is divided into a training set and a test set. This binary scenario presents a contrasting case. The highest F-score in a scene R, as can be shown in Table 8, is reached by the text outside the text 0 with 1.87, although within text reach only 53.53. As concluding remarks with these experiments, we can say that if we compare these results with the previous works, particularly Hempelman et al. 2005, we find that span is not as relevant for the prediction of the informative state as LCA, although the accuracy is close. In that work, they reach an accuracy of 80% for English using a dichotomous labeling, inspired in the work of Ellen Price, by the way, and 478 known phrases of written discourse, where in our study, a scene R, the dichotomous labeling, reached an accuracy of 79 for Spanish. As a reminder, a work in Spanish with this methodology have not been done before. The Pearson correlation showed that there is a certain predictability between the measures and the text, whether it is the complete set, the scene C, or only the binary one, the scene R, the last one that we will look up. The variance analysis is allowed to rule out that a random segmentation is better than these groupings, although the graphs show the complex task of a fine division between informative states. The experiment with random forest classification with Estince show us that only 2 of them are predicted by the measures, being LCA with the interior bag of words, the one that offers more information for the classification. And the binary case, LCA also shows a higher weight, where in fact higher accuracy and a higher F-score are achieved. Something important about this experiment is how, although span seems to have better results in other experiments in the previous work with English, it is not the case for Spanish. Well, that will be all. Thank you for your attention.